Here we go. 2C. Hope that worked. What do they want me to find? Bit of a problem because I do have a pair right here, which means I can. I do have a pair right here, which does mean I can use the sine law, but I don't have this one here because I don't know that side. But Taylor, could I use this side to find this angle? Yeah, and if I know two angles, how many do I know? I just saw the light go on. What? 3. So you know what? I don't have to give you enough information to find your angle directly. As long as you can find any two angles, it's a triangle. What do they all add to? 180. Do you want me to keep going, or did you just see how to try it yourself? Okay. By the way, I would consider that a B plus level. That's a tricky question still. Little curveball there. But you know what? I'll probably put one like that on the test. 10 like that? No. 1? Sure. Any others? 4? Okay. So they want the angle between the lines of sight from the freighter to the cruise ship and the radar station. You know what? I think they want from the freighter to the cruise ship and the radar station. I think that's the angle that they want. That would be the angle from the lines of sight from the freighter to the cruise ship and the radar station. Is that okay? Did you figure that part out or not? Yeah? Okay. Now, for the sine law, I always start out with a pair. There's my pair. It's going to be, and you'll notice now in our day 2 of using the sine law, I'm trying to see if I can go straight to plugging in numbers. It's going to be the sine of 100 divided by what's across from it equals the sine of the mystery angle divided by what's across from it. That's the setup. Now what? Well, we cross multiply a little bit. We'll get sine theta. I think when you cross multiply, you get 4.5 times the sine of 100. And then over here, you would have a 6.3, but to get the sine theta by itself, I would divide by 6.3. Did I go too fast, or were you okay with it? Are we finding an angle, or are we finding a side? What do we have to remember to do when we're finding an angle? So now this was a bit more complicated. What we're going to do is we're going to change this to a decimal. First of all, we're going to open my calculator. Okay, we're going to change, make sure I'm in degrees. Am I? Ooh, I am. We're going to go 4.5 sine of 100 divided by 6.3. That's not the answer. Theta is not 0.703 degrees. That's the sine of theta. Now my final step, I have to go second function sine of that decimal. The angle is the back say 44.7 or 45 degrees? Is that what it says in the back? Yeah? There. Okay. You'll notice, Sam, today is lesson 8. All I got's lesson 9. I'll probably do a couple of practice quizzes and maybe a nice unit review. So if we're trying to budget, I think your test is going to be not next week, but the week after, Tuesday or Thursday. And I'll give you more details next week. Much shorter unit. The cosine law. Dun, dun, dun. Lesson 8, the cosine law. The last of the trig laws that I know. There's other types of trig where you're not looking at triangles, you're looking at circles and things like, but in terms of solving triangles, Courtney, all I got in my bag of tools is SOHCAHTOA, Pythagoras, angle sum of triangles, sine law, cos law. That's it. And I got a math degree. I did 4 years of university math. So let's find this. From last class, remember that the sine law is used to find sides or angles in a triangle when you don't have a right angle. A right angle. So, quick review of the sine law. Joe, maybe you'll pick it up. If not, watch the video. Let's try this one. Find AC, or in our new notation, little b. First thing I ask is, do I have a pair somewhere? Where? I don't know both of those. I do. You're right. I do have a pair. Where? I'm going to tell you, don't circle it because it really wrecks your diagram. I know both of those. No, I don't. Taylor, why do I know angle C if I know the other two? So let's fill this in. Can you guys go 180 minus 76 minus 41? How big is angle C? And there's my pair that I can use to solve the rest of this. What'd you get? Oh, sorry? 60, 63? Anybody else? I want some confirmation. Yeah? Okay. Let's see, Devin, how good we are if we can go straight to plugging in numbers. It's going to be the sine of this over what goes with the 63-degree angle? The 10 equals, well, I want to find little b. What goes with little b? The 70 sine of 76. Now we cross multiply. We're going to end up with b times the sine of 63 equals 10 times the sine of 76. Alex, how would I get the b by itself? More specific, because there's lots of things to do. Divide by both sides by what? Yes. b equals 10 times the sine of 7. Whoop. Pen's acting up here. Come on. Divided by the sine of 63. And I have no idea what that is, but can you try that on your calculators? (10 times the sine of 76 divided by the sine of 63. Or you could just move one over next to Erin and copy off of her. Just saying. And Erin, who's normally to your right? No. Okay, to your right is blank? Gotcha. What did you get, Adam? Go practice, because you got the weird calculator, right? Sierra, what did you get? 10.89. Anybody else? 10.89? Seems about right. Sure. So here's the key idea. To use the sine law, you need at least one angle and its opposing side. Or as I've called it, you need a pair. What we're going to ask ourselves today, Shay, is, okay, what if you don't have a pair? What if angle sum of triangle doesn't help you find a pair? What if you don't have a pair? Well, there's one more rule. If you don't have an angle and its opposing side, if you don't have a pair that you both know, you can still find out the piece you're looking for. You need the cosine law. Here's the cosine law. Danielle, can you read it to me, please? This first part, what does that look an awful lot alike? Matt, it looks an awful lot like, good gosh, Pam, come on. The Pythagorean theorem. But Pythagoras only works when you have a right angle triangle. As it turns out, Joe, this little part right here takes care of the fact that you don't have a right angle triangle. I think of it, Alex, as Pythagoras squished. And it's that minus part that does the squishing. Now, believe it or not, technically I could now stop and have you do the homework because you already know what little a means, same as it meant yesterday in the sine law. You already know what little b means, same as it meant yesterday in the sine law. Adam, you already know what little c means, same as it meant yesterday in the sine law. And you know what BC and cos big A, oh, you can figure out what angle is cos big A, which angle is big A. By the way, it's called the cosine law because which trig function appears, Jordan? Cos. Okay? When using the cosine law, you just need to remember that the angle you know or want to know is big A. Then the other two sides are B and C. Here is a great example. It says find side XZ. Okay? Well, the cosine law has letters A, B, and C in it. What's the angle that I know? What letter do I know, Liam? Well, in this triangle, though, what do I call that? Big A. Which, Bender, makes this side across from here, xz, which is what they want me to find, little what? Bender? Makes this side across from here, little what? Did you say little a? Pretend you did. Nod your head and smile, okay? These two are B and C. It doesn't matter which one you put where, but just put one of them in for the B and one of them in for the C. That's the cosine law. So it says relabel angle Y as angle A. This means that A is the side XZ, which is what they asked me to find. And B and C are 5 and 8. So start with the formula. A squared equals, what's B? Sorry? No, that's an angle. What's little? These are little sides, right? What's B? Either one of these. Pick one, Jordan, and be consistent. Do you want 5 to be B or do you want 8 to be B? Doesn't matter, but pick. Okay? 5 squared plus, then what's little c? 8 squared minus 2. What did you say B was? See how you, by the way, you can figure it out by looking at the equation and just backtrack, right? What did you say C was? 8 cosine of, what did we say big A was? 70. See, this is where I've yelled at you to, specifically for this, to get a good calculator. Because if you have a good calculator with a 2-line display, you should be able to type in 5 squared plus 8 squared minus 2 times 5 times 8 times cos 70. And I have to close a bracket off on mine and get that answer right away. It's long typing, but it's there. Adam, figure out how to get that answer on your calculator. I think actually you can type it in as is as well, except the very last part is going to be 70 cosine and then equals. You got that okay, Em? Anybody not able to get that? I'll come help you with your calculator. Yes? But we're not done. See, here's what we found. A squared equals 61.638 dot dot dot. It's not what they asked me to find. They didn't say find A squared. Once again, how to get rid of a squared? And I'm going to get clever. I have an answer button on my calculator. Why retype stuff? I'm going to go square root. I'm going to go, oh, there it is, of my last answer. 7.85. That's the cosine law. Identify which angle you know. Call that big A. Jordan, the one from across from that angle, you'll call little a. And then B and C are the other two sides. By the way, we would have got the same answer as if you called B 8 and C 5. Because when you see, you'd still have a 5 squared. You still have an 8 squared. And you still have a 5 times 8 in the middle there. It'd just be an 8 times 5, which gives you the same answer. I find the two most common mistakes here, Courtney, are typos. It's a long equation. And kids forget to square root at the end. So don't do that. Oh, have I yelled at you about getting a good calculator to help you avoid the typos? Yes. Let's try another one. Example 2. What do they want me to find? Call that little a. Oh, what will I call this angle right here? By the way, you know how else I know to use the cosine law? Sam, I know to use the cosine law, look up, when I have side angle side. so I can tie in some geometry from last unit too. It wants us to walk through all of the relabeling. Here's our equation. Let's see if we can plug and chug. Here we go, here we go, here we go. A squared equals B squared 3 squared. By the way, so you can even do some of this in your head because, Matt, you could have just gone 9, 3 squared, right? Plus 4 squared. Could have just gone 16 if you're really in a rush. Minus 2 times 3 times 4. Cosine of what, Matt? 115 degrees. What do you get for A squared? And then square root, what do you get for A?
Good afternoon, Pitt Meadow Secondary. If I could have your attention for a minute. I note that...
Let's keep going. 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 115, close bracket. So I get you get A squared equals 35.142838, blah, 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 blah. I'll write 35.14. That means A is going to be the square root of that. 5.93. Example 3. How many more are there? Well, Devin, we also have to look at finding an angle, which that's the only place the cosine law kind of sucks. Finding angles with it. You can, it's just work. Meanwhile, example 3. I notice I have side, angle, side. This is a job for the cosine law. They want me to find the distance of the lake TU. Let's call that A, little a. Let's call this big A. Find it on your own. I'll do it up here without saying anything. Let's see if we get to the same place. Decimals? Oh well. I got a calculator. Isn't that right? You get 5.07? I really like this one here. You need to realize how glorious this was for map makers before we had GPS. You realize we were able to find out how long the lake was without taking a boat all the way along the lake and measuring the stupid thing. Map makers used this all the time. It was much easier to tromp a distance in a straight line on a nice straight trail. And you could angle this whichever way you want to, measure the angle between it pretty easily, and you could get, without actually, especially if this was inaccessible terrain, the exact distance across it without actually having to go there. Called indirect measurement. Oh, map makers loved it. Now we have GPS, fine, but only had it for about 20 years. Devin, you can use the cosine law to find a side. You know what else you can use the cosine law to find? Angle. You can only use it if you have all 3 sides like this. Just remember, the angle that you want to know, relabel it big A. Why? because the only angle that appears in the cosine law is big A, so I may as well call it big A, so that's why I want to get by itself. Simon, what angle do they want me to find an example for? I'm going to call that big A. Which of those three numbers then becomes little a? The 10, the 8, or the 7? Ah, little a. Once I have those two, Binder, the other two don't matter. I'll go B and C. Okay. I start with the formula. A squared equals B squared plus C squared minus 2BC cos A. A squared equals B squared plus C squared minus 2B C cosine of mystery angle A. A. This is more complicated, Danielle. We're going to use more steps. First thing I'm going to do is actually get rid of all these exponents. What is 7 squared? 7 times 7? This is 49 equals, what's 8 squared? 64 plus, what's 10 squared? Minus, and then in front of the cosine, I have a 2 times 8 times 10. 2 times 8 is 16 times 10, minus 160 cosine of big A. Alex, are we finding an angle in this question? You know what we're going to do on our very, 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 very last step? What have we always done on our last step to find an angle on our calculator? This is going to involve second function. But first, we need to get the cos by itself. Look up. First thing I want to do is move these two guys over. In front of the 64 here, positive or negative? So how will I move it over? Minus it. What about in front of the 100? Positive or negative? How will I move it over? Okay, so the next thing I'm going to write is this. 49 minus 64 minus 100 equals negative 160 cos A. Is that okay, Adam? What am I trying to get by itself? The cos A. Is the cos A by itself? Not quite. What's in front of the cos A? What's it doing to the cos A? Adding, subtracting, multiplying, or dividing? So how will I move the negative 160 over? Okay, so now I'm going to divide this whole thing by negative 160 and divide this whole mess by negative 160. Do I have more room? Nope. Okay, move over. I'm going to get this. 49 minus 64 minus 100, all divided by negative 160. That equals cos A. I'd like to evaluate this. How many numbers do I have on the top, Aaron? 3. I better put the top in brackets on my calculator, or you can do the whole top line, Emily, on your cheaper calculator. That minus that equals, divided by negative 160 equals, that'll also get you there. But if you got a good two-line display, you have to put the top in brackets. Bracket 49 minus 64 minus 100, close bracket, divided by negative 160. And I get this. The cosine of A equals 0.71875. Alex, what am I going to do in my final step now? This is the cosine. How do I find the angle? Second function of that decimal. Second function, that decimal. You know what the angle is? 44 degrees. This is, Devin, why I said finding an angle with the cosine law, a little more of a pain. Although, not too bad. angle A equals 44 degrees. Did you all just turn the page? You know what we would do if we were smart at the top of the page? We would go a squared equals b squared plus c squared minus 2bc cosine big A. I don't know. What's the only thing I said you had to memorize? No. I'll give you that. Some of you will just end up memorizing. It's fairly alphabetical-ish. Here's how I remember it, Jordan. See that letter? It's that letter. The other two are the other two sides. Oh, and don't forget a minus 2 in front. That's honestly how I memorize it. It's Pythagoras squished. Ready? A freighter is entering a harbor whose entrance is that wide. If the distance from the ship to each side of the harbor is that, find the angle the harbor master must steer between in order to make it safely in. You know what? I think they want us to find that angle right there. Danielle, what letter will I call this angle from this equation? Now, as soon as I do that, one side I do have to get right. Little a. Which is side little a? The other two, it doesn't matter. I usually put B on the top and C on the bottom, so it's kind of alphabetical, but whatever. Okay. Normally, at this point, I would write out the formula. Did we write out the formula at the top of the page? Okay, let's see if we can go straight to numbers. 0.5 squared equals 4.1 squared plus 3.8 squared minus 2, 4.1, 3.8, cosine big A. Before we go to our calculator, Adam, we need to get the cosine by itself. Now, stop for a second. Here, Adam, I actually did the squareds, but I think it's just as easy for me to leave the squareds on there for the decimals and just type that into my calculator. So I'm going to do it that way, be a bit lazy. How would I move this 4.1 squared over? Minus it. How would I move this 3.8 squared over? Also minus it. I'll have now on the left side 0.5 squared minus 4.1 squared minus 3.8 squared equals negative 2 times 4.1 times 3.8 cos A. Is that okay so far, Sydney? Oh, and Sydney, in the previous example, I actually, because it was easy to do, went 2 times 8 times 10, 160. I can't do this in my head. You know what? I'm just going to leave those three numbers separate, and I'll type them into my calculator. Here's what I'm going to say. Courtney, there's a negative, and a 2, and a 4.1, and a 3.8, and they're all multiplying. So how will I move them all over in one fell swoop? They're all multiplying. How will I move them all over? I'll divide both sides by a negative 2, a 4.1, and a 3.8. A negative 2, a 4.1, and a 3.8. And when I do that, I'll get the cosine of A equals 0.5 minus 4.1 squared minus 3.8 squared, all divided by a negative 2, a 4.1, and a 3.8. Liam, how many numbers do I have on the top? More than 1? Brackets. How many numbers do I have on the bottom? More than 1? Brackets. This is what I'm going to type into my calculator. Bracket. 0.5 squared minus 4.1 squared minus 3.8 squared, close bracket, divided by bracket. Negative 2 times 4.1 times 3.8 close bracket. And the angle is 0.994. Oh, no. That's not the angle. By the way, the most common mistake on this, Joe, is kids forget to do the final step, which is, Alex, what? Second function. Angle A is going to be second function. How do I know to use cosine? It's the cosine law. It's the cosine. So that's how I know second function cosine of my last answer. And I think it's going to be pretty small. 5.8. Is this right, by the way? Do you get 0.99? Let me double check my math. 0.5 minus 4.1 minus 3.8. All divided by negative 2 times 4.1 times 3.8. Is that right? Is that what you guys got too? Pretty small. 5.8 degrees. This person has to aim very carefully. Sam, let's cosine law. A little trickier than the sine law? Yeah. Although if you have a good calculator, too bad. So, holy smokes, you got 35 minutes. No homework for the weekend if you play your cards right. Try number 1. Try number 2. Three is good. Four is good. Five is good. Skip 6. Seven is good. You can probably expect a take-home quiz either Tuesday or Thursday that's going to have some sine law and some cosine law on it.